serious. We have an exit to my left and also to my right-hand side. So as soon as the fire alarm goes off, please, you would do well to make your way either through the exit on my left or by my right-hand side. There will be people to direct you to the muster point. Please, in case you forget anything in the hall, don't come back until you are cleared to do so. Here we say when you see something, you say something. So should you see any unsafe acts, please be quick to inform me about it so we can take a drastic step about it. And let us remember finally that the person that is most important for your safety remains you. I wish us a safe meeting, both for those who are joining us virtually and those who are seated in the hall currently with us at the PTF building in Abuja. Thank you so much for listening. So let's put our hands together as we invite the Abuja chapter coordinator, Dr. Eunice Ajayi, for our opening remark. Thank you.
Thank you, Mr. Tuwasu. Good morning, everyone. This is Abuja chapter, NAPI Abuja. Thank you for joining us this morning to our July NAPI meeting. Today, we are having a very special topic today, which is insight into the architecture and petroleum system elements of upper Cretaceous deposits in the Nigeria Intracratonic basins. I also want to acknowledge the presence of NAPE Abuja President, in the presence of Mr. John Bosco Uche, and also our President-elect, Mrs. Olajimoke Ajayi. Thanks for joining us, and a host of others joining us online. I can see some of our fellows, NAPE fellows, and also very active members online. Thank you for joining us this morning. Like I said, on behalf of the Executive Committee and also the NAPE ESCO, Abuja chapter, welcome today. And like I said, today we are going to deviate from the Niger Delta basins, and we are going to go into the Cretaceous Intracratonic basins. And when we talk about the frontier basins and the one in the Intracratonic, we talk about the Chad basins, the Sokoto basin, the Bida basin. And it's also interesting to know that we are able to find oil in the Bida basin. These are basins these days, and it's just cheering to the government, to Nigerians, that we have extra production of oil in our interland, in the interland basins. And it's so special to me also because I served in the Sokoto basin, and then the Sokoto basin is synonymous to limestone deposits, and then the popular Northern Cement, which is Sokoto Cement company, it's actually is mined. We mine the cement from the limestone that we use for the Sokoto cement from this basin, the Illimidian basin. And luckily, a few years ago, like in 2023, I was part of the panel review on EIA for the proposed Sokoto Basin project, which is, that is synonymous to the frontier explorations. So today, what we are going to be having today is an interesting topic, and I'm sure our speaker for today, Dr. Mutari Lawal, is ready to really dive into the topic. Before I proceed, I would like the president of NAPE, in the presence of the person of Mr. John Bosco, to give us a remark. Mr. John Bosco, please, can you address us?
Yes. Abuja chapter coordinator, confirm you can hear me?
Yes, we can hear you.
Okay, perfect. All right. No, thank you very much, and good morning to you and everyone. I see the room is again busy as usual, as you typically would do, and quite excited that we'll continue to do these technical and monthly business meetings in a hybrid format where we've got lots of folks online, but also people in the room. So I really want to say thank you to you yourself as our chapter coordinator and the entire executives that are working with you to deliver this and continue to provide a platform to our members and non-members alike as we continue to share the knowledge in the industry. So thank you very much. And for everybody, let me just add few that indeed we will continue to know what we are known best to do. The topic that we're going to be listening today actually is not Niger Delta, it is Cretaceous, it is frontier. But if you've paid attention to the media, in most of the press statements we've released, we have been very vocal and very strong that we need to do more in the frontier basin. And that frontier basin, clearly includes what we're going to be listening and hearing today. And it's our thinking as explorers that there's a lot more we can do with the right data sets, with the right knowledge to deepen our understanding of these basins, be the Sokoto, the Chad Basin, the Benue Trough, the Anambra Basin, and the rest, to find gas that we do need, especially at this energy transition period. So we are quite happy that we have an opportunity to have this discussion, to know more, and then also to network, as we typically would do. So on behalf of again, from national level, as already mentioned, the president-elect is on the call, and I believe some other ESCOs are going to be joining. If not already joined, I see the UK Europe chapter coordinator is already there to support Abuja chapter. We're always here to support you in whichever way. But thanks for everything you do for us, especially each time we're in Abuja. You've been quite a good host, and you've been helping us to do all the stakeholder engagement and advocacy that we'll continue to do. So on that note, let me yield the floor back to you, our Abuja chapter coordinator. And please, everybody, stay relaxed and enjoy the session.
Thank you very much, P, for that insightful presentation and introduction. Thanks. And also, I would like to introduce our chairman for today in the name of Mr. Hussaini Mohammed Aliyu. Mr. Hussaini is the manager, Basinal Analysis, NNPC Energy Services Limited. You're welcome, sir. He's going to share our program today. And also, I want to also acknowledge the sponsor of this meeting this morning, and is one and only Mr. Mark Jaja from NUPRC. He's actually sponsored our program this morning. Thank you, Mr. Jaja, for funding this program. And I want you to relax and have fun as I invite the chairman to introduce Mr. Dr. Mutari.
Yeah, good morning, all. Welcome to today's technical meeting. The presenter today is Dr. Mutari Lawal of the University of Abuja. So if he can make him... Dr. Mutari Lawal of the University of Abuja.
So I'll be reading his citation. Thank you, sir. So Dr. Mutari Lawal is presently a distinguished lecturer in the Department of Geology and Gemalogy at the University of Abuja, Nigeria, contributing to academic and research excellence. His academic journey and professional endeavors reflect a deep commitment to advancing the field of geoscience globally. Before now, he served in the same capacity at the Usman Danfodio University, Sokoto. Dr. Lawal's academic credentials are testament to his expertise in the petroleum geoscience. He earned his BSc degree in geology from the prestigious University of Ilorin and Masters in Science in Petroleum Geoscience from the University of Manchester, United Kingdom. He advanced his career by obtaining a PhD in Sedimentology and Petroleum Geology from the University of Malaya His research interests are wide-ranging, focusing on clastic and carbonate sedimentology, stratigraphy, and hydrocarbon basin analysis. Additionally, Dr. Lawal's work encompasses unconventional hydrocarbon resources and carbon hydrogen storage. He has worked on the Sokoto Basin and the Williston Basin, USA. He has scores of peer-reviewed publications and numerous scholarly presentations to his name. Dr. Lawal's contribution transcends the academia. He leveraged his extensive knowledge to address global challenges, particularly in Nigeria. His commitment to Nigeria's progress is exemplified by his role as Secretary of the Green STEM Educational and Charitable Foundation, advocating research and innovation. Dr. Lawal is affiliated with esteemed professional organizations, such as being an active member of the Nigerian Association of Petroleum Explorationists, NAPE, Nigerian Mining and Geoscience Society, NMGS, and Society of Petroleum Engineers, SPE, and he is also COMEX certified. Dr. Lawal is a naturally motivated professional who is eager to engage in academia and industry initiatives. Please, can we put our hands together as we welcome him one more time to make his presentation?
Thank you. Let me begin by thanking the NAPE executive, the NAPE national chair, as well as the president-elect. Then I'll also recognize the NAPE UAP chair, the distinguished, all distinguished audience, and those who are online. So today, we're going to be looking at insights into the architecture and petroleum system elements of upper Cretaceous deposits in the Nigerian Intracratonic basins. So I know this is quite a broad topic. So the idea is to try to maybe open as a background to cratonic basins in general, looking at global examples and why they are important as hydrocarbon provinces. Then we, at some point, will narrow down to a Nigerian case example. And then that will be followed by a discussion in a wider perspective. So as a result, we'll be looking at the background to intercratonic basins today, and again, the global examples and the Nigerian case study. Then we'll talk about the data and analysis and move forward to the discussion and then conclusion. I want to say that as a catch, the data for this presentation comes from my ongoing research, and I have also taken from previously published materials, quite many of them. And but whatever, it also includes my collaboration with other people. So whatever I'm saying here today will be taken as my own opinion. And I know the audience is very rich. I also look forward to your constructive contribution because I am a young geoscientist, so I'm open to gaining or benefiting from this discussion. So this is what we have, cratonic basins. Basically, these are basins that are located, far from the craton margins, but undergoing, surrounded by massives or basement massives, undergoing differential subsidence. So they are quite, most of the time, associated with rift elements or rifting, but in some cases, no rifts formed at all. That's why you see there no major rifting, but Some are associated with rift, as you will find out later. And so these are global distribution of hydrocarbon provinces that comes from intracratonic basins. So we have quite a number of them. We have so we have some in Australia here, and we also have in South America, Brazil, and we have some in North America, Canada, and we have more in African region, which will be my main focus today. And so broadly speaking, you can have or cratonic basins, either having them as epicratonic or intracratonic. Those of epicratonic are those, sitting on top of lithosphere as well as oceanic, granitic lithosphere and oceanic crust. So the intracratonic basins will be my focus. So this is what we have, intracratonic, basically surrounded by Precambrian massifs or older basement rocks. So as a result, they have a peculiar input. Sometimes if it is associated with rifting. So in Africa, which is my case study, we have them distributed quite nicely. And we have the rift association, like the Benue Trough and those of the Tenere and Tami basins. So quite important, because these rift elements would have an impact on how sedimentation proceeds and the history of the basin generally. So I'll be looking at the intracratonic basin also can be terragenous if it is dominated or having little marine influences, and it can be carbonate, those mainly marine. And so in essence, these basins are very important. A lot of hydrocarbon has been found in these basins, somewhere in Libya and even in Congo, for instance, as well as Taudeni basins. So the Bida Basin and the Sokoto Basin, or the Illuminated Basin, let's not go to Sokoto Basin just yet. So the Illuminated Basin is part of the cratonic basins. So the Bida Basin is classified as part of the cratonic basin or intracratonic basin because this is surrounded by a basement massif. You have the southwest and the northern basement complex of Nigeria bounding the Bida Basin. Rifting has been associated with the Bida Basin, but I think what I have here that you see is an example of an intracratonic basin that is producing. This is the Williston Basin, North America, a basin spanning between Canada and the USA. More than 4 billion barrels of oil is being discovered here. What is important is that it started as a rifted margin, later transformed into intracratonic basins. So very prolific. So a cross section, because the reactivation of faults and structure within the basin led to formation of some anticlines, such as the Nesson anticline, very important. The hydrocarbon that is being produced is found or basically coming from the upper and middle tree forks, as well as the middle back information, which is dolomite and sandstone. Also, we have unconventional resources dominating the middle back in reservoirs. So the source for this hydrocarbon are coming from the lower Bakken and the upper Bakken shale members. So my aim of bringing this global example is just for us to have an idea, because as I said before, this is a broad topic. So, so we have to find a way to narrow down. If not, we'll spend months trying to exhaust this topic. So this is another one, Hudson Bay in Canada, producing, and in all those basins, China. And we have another one in the Middle East, the salt basins. So this is associated with salt tectonics and basin inversion. So these, what is important is that cratonic basin seems to have a very predictable, has a high predictability when it comes to the early Paleozoic succession, but later basins are more, they are more controlled by hydrodynamics or local hydrodynamics. So this is the West and Central African rift system. So the rift elements are quite abundant surrounding the intracratonic basins. So here we have many, it's a prolific zone, and we have many discoveries already. So my main interest, this is the Bida Basin surrounded by the massifs, and this is the Illimeden Basin surrounded by Precambrian massifs as well. So the Bida Basin has an underlying rift elements. It's essentially, it's an extension of the Anambra Basin northwest, where hydrocarbon potential is also very high. But exploration is still ongoing. The recent idea is that there are rift or fracture influences in this basin. So that is going to influence exploration or development of fascists. Recently, there has been some discussion around whether Bida Basin is companion to Maastrichtian basically, or is older. That will continue to be part of the discussion. So the Illimeden Basin, I'm not going to focus much on the Bida Basin because it's better studied and having more data compared to the second cratonic basin, which is the Illimeden Basin. At least we have some seismic and as well as core data on the Bida Basin. But for Illimeden Basin is less studied. Data is very scarce. So the Illimeden Basin and Intracratonic, cutting across 5 countries, Algeria, Mali, northwestern Nigeria, as well as Niger and in Chad. So this, if you zoom in, we have the structural map here. So there are some lift elements such as the Agadez line, and we have made a discovery where these rift elements have contributed to hydrocarbon distribution. So because of the complex nature, they have complex history when it comes to a fully intracratonic basin, because the model for Sokoto Basin is still SAG, but it's not totally disengaged from the Gondwana breakup or the rift elements. So there are even thoughts that we might still have deeper sections than we currently imagine, especially in the Cretaceous succession. So this is the basin. It started somewhere in the north with a continental intercalare. So the basin gets younger towards the east and then the southwest. Okay, so the extension of this basin into Nigeria is the Sokoto embayment, otherwise known as the Sokoto Basin. It's my main focus today because it does not have sufficient data. Exploration activities has been stalled as a result of poor knowledge of the geology. There has been significant input from recent studies. So this is the stratigraphy, like I said. By the way, the whole Ilimiden Basin has some diachronicity. You have in some places where you begin in Permian to Triassic as well as Jurassic. But in Nigeria part, we are looking at basically a basin that has Mesozoic, Jurassic, oldest part known as the continental intercalare. So this is what it looks like, the general stratigraphy of the Sokoto Basin. So we have this basal part, the Ilo Gundumi Formation, or the Gundumi Formation, the equivalent of the Ilo Formation that is in the northern Bida Basin. This is overlain by Cretaceous, Upper Cretaceous deposit. So the Rima group having tide influence deposit overlain by shallow marine elements, the Dukameji Formation, then the Wuruno Formation, just like the Taloka Formation. Since this is our interval of interest, the overlying Sokoto group that is rich in shale will, as a result of inheritance, we will talk about it because it has input in the discussion of the petroleum system elements, and then the overlying continental terminal of using or late ages. So I'm just going to narrow this talk down. I'm just going to focus on the fascies and the distribution of these fascies, then talk about the I will talk about the sequence stratigraphy of deposits that I have studied. The aim is for me to be able to bring out some predictability to the exploration of this basin. Because as we know, the Sokoto embayment has no seismic, no well data. The nearest well data comes from somewhere in Niger, Combretum. So my focus is going to be, this basin has been studied, many study workers such as Kobe and Peters, and we also have Zaborski and Morris, and we have studies from other, more recently, I have published a paper on this with some collaborations. So this will make part of what I'll be talking about today. So the Upper Cretaceous of the Sokoto Basin or Sokoto embayment is divided into, or is known as the Rima group. And the Rima group is divided into 3 formations: the Taluka, the oldest, then overlain by the Dukamaji Formation, and then the Wuruno Formation. So the whole Upper Cretaceous is overlain by the Sokoto group. So this is some of the fascies I have described, many of these coming from Lawal et al. 2023. So previously, we believe that, or what is held is that the Taloka Formation is a tidal flat deposit, especially work by Kobe and some others, people, Adetunji and Kobe as well. So, but I found that the Taloka Formation occur in four main fire schist element or fire schist association. We have delta front, and we have tidal deposit, and then we have also delta plain deposits, but this one is fluvial influenced. This is because here what we have is what we have in this cases is that we have wave influences giving us coarsening profile separated by units that is carbonaceous shale or lignitic mudstone. Then when you go up, there is a separation between the delta front or the wave influence delta front deposit. There is some pedogenic layer here, which is moderately well developed. That's indicating that there is a gap or a pause in sedimentation before you have more fluvial influenced. So this is the succession, basically, as interpreted by Lawal et al. 2023. So we have below a wave influence, and as you go up, you increasingly have fluvial influence. Then what is interesting about Sokoto Basin is that it is demarcated by zones of mudstones, which are especially carbonaceous and rich in organic matter. So this is what I believe that will give us a sense of prediction later. The delta front deposit capped by carbonaceous unit is typically 8 to 10 meters. So this is some of the outcrops I'm talking about. So you see this separation between one delta lobe overlain by another deltaic succession. The same thing here. That is the typical element of reservoir interest, the sandstone overlain by mudstone layers. So the same thing here. This I interpreted because it has some elements of hummocky cross stratification, and this dirty looking like but highly rich in organic matter. This is a shore face element of the delta front. So here you have laterally accreted deposit. This is toward the upper part of the Taluka Formation, where you have increasing fluvial influence. So in terms of distribution of these fire schist, what we find is something that looks like the center or the thinning of the sandstone element towards the southwest, while it increases in thickness the northeastern direction. So I did some analysis using ternary plot to really identify what kind of coastal environment does Taluka Formation belong. So, this is one of the most interesting or new insights to this. I've been able to locate that the Taluka Formation falls within a tide and wave influence as well as fluvial influence deposit. So if you look at the model that I constructed, so you have these sandstones with channel bars, thinning this direction. That is southwest. So there is a center or the axis of that deltaic, you would have thick sandstone. And towards the left this way, it also thins away. So this is an indication of a progradational delta. So Lawal et al. 2023, we did more of, we tried to shop for an analog, modern analog. The first discussion is we compared the Taluka Formation having distributary channels separated by tidal channels, whereas it's similar to the Niger Delta, the modern Niger Delta, where you have wave and tide dominated system. So, but because of the way the stacking of the Sokoto, the Taluka Formation, which is more progradational with an aggradational parasequence state. So it looks more like a Trosan basin located in northern Brunei. In the Brunei Bay, you have a tide-dominated and wave-influenced deposit. In this basin, there is an associated outcrops that has been used to confirm the progradation and the deltaic elements, but I'm going to show you that one later. So the overlying Ducamaje Formation is basically laminated mudstone overlain by limestone deposits with intercalated bone beds. So the interpretation based on richness and succession, we have interpreted Ducamaje Formation as basically a shallow marine. But Lawal et al., Lawal and Hassan 2023 interpreted this as a restricted nearshore marine, but there is no sufficient element or evidence that there is restriction. So we have an open shallow marine. So this is the stratigraphy interpreted for the Ducamaje Formation, a shallowing upward sequence, and it's exposed at this level. So this what sand-rich unit that cap the Ducamaje Formation indicates that it is on its own a transgressive element or sequence. So again, for the Ducamaje, what you have is basically widespread, regionally correlated marine deposit, which means that it has been postulated previously that the Ducamaje Formation was formed at the time when the TCC and the Gulf of Guinea, connected. So the reviving the so-called Trans-Saharan Seaway, this correlation supports that there was a connection between the TCC North and the Gulf of Guinea. So the overlying Wuruno Formation is tidal influenced. So what we have at the base is ripple beds, asymmetrical ripples with some bioturbated lenses. This is similar to what the Taluka Formation has. Previously, again, there is often a confusion how to demarcate between or differentiate between the Taluka Formation and the Wuruno Formation when the Ducamaje wedges out. Okay, but in this study, I've been able to isolate that at the base, you have flacer-bedded ripple sandstone overlain by a succession of tidal bundled elements indicating shallowing upward. And towards the top, you have more muddy material and capped by this brownish ferruginous and fossil-rich unit. By the way, this fossil-rich unit also cap the top of the Ducamaje Formation. So this is an indication also that the Wuruno Formation is transgressive. This is contrary to Peter's 1971, that believed that the Ducamaje, the Wuruno Formation is not transgressive. And he said that it terminated as an embayment. So this is the kind of tidal bundling that we have. We have quite a number of them. So it's an indication of a transgressive or one of the best evidence that there is tidal deposition in the Woruno Basin. So this is the stratigraphy. By this grayish, thinly laminated with little sand layers or thin sand layers in there is what typify the succession in the Woruno Formation. So as you go from the base, you move from sandy ridge into this rhythmic bedded sandstone. Then towards the middle, you will have a carbonaceous element, but still retaining the rhythmicity. So this is a nip spring example of the tidal cyclicity. So it's a pointer that tide was very important. So the overlying inherent Sokoto group is important. It's shale dominated, intercalated with some limestone or mouse, and at the top it grades upward into fossiliferous, highly fossiliferous Columbina formation. So the shale belong to the Dengue formation. So our interpretation is that the thick shales of Dengue and the Columbina limestone represent another sequence of marine transgression in the Paleocene. So we have tried to make some correlations. I think the best correlation datum I found is to use the ferruginous fossil-rich, dark brown, paved limestone or shore-face mudstone as a demarcation that punctuates the transgression into the Nigerian part of the Ilumidem Basin. So the model for the Woruno Formation is tidal flat that is, vegetated at some point. So this model, I must say, points to the fact that since we have upper tidal and upper intertidal element, it shows nearness to the shore. So my thought is that the Woruno Formation terminates as an embayment and not in continuity with the southern counterpart or at this time. So this is the summary of the stratigraphy, Upper Cretaceous, moving from Taluka Delta into the limestones. And so this stratigraphy indicates an aggradational parasequence set. And since I call it aggradational because you have three transgressive sequences sitting on top of each other. So the only reason that could happen, or I allude to that, is that there must be rapid sedimentation, and for you to have that kind to happen, the basin must find a way to generate new accommodation while sedimentation is ongoing. So the aggradational set for the Taluka Formation is as a result of the fact that sediment supply was in pace with accommodation generation. So I carried out some geochemical analysis. The takeaway is that there are the carbonaceous zones are rich in organic matter. Sometimes you have more than 5 TOC level, but majority of them did not make it to across 1.0. If I put the TOC cutoff as 0.5, then we might have more materials that get into the source rock potential level. So I also carried out some petrographic, organic petrological studies. So what I found out that the organic matter within the Sokoto Basin, Upper Cretaceous, they are dominated by a terrestrial element based on the dominance of vitrinite elements. So this is an indication that these were derived, or the organic matter present in the Upper Cretaceous of Sokoto embayment is terrestrially derived, and an indication that we may have more gas in the basin if at all they are present. One thing though is that there is a not sufficient maturity. Only a few of our sample make it to the maturity level. So, but as I will project later, that going deeper and going by the geometries of the sand and the shale element I have identified, it is possible to predict more prospective areas within the basin. And this will help to de-risk or encourage investment interest. So I went further to try to do a regional correlation of the Sokoto or the Ilumeden Basin. Hitherto, it has not been, it has been challenging to do this, but I think there might be some correlation line not well aligned. The point is that it is now possible for us to be able to correlate with the Taodeni Basin, the Malian part of the Ilumeden Basin, the Niger part of the Ilumeden Basin, and the Sokoto section of the basin. So this will help in exploration activities. So a further correlation with a number of basins and how the Upper Cretaceous were correlatable with global rise in sea level. Okay, now this diagram here was the model provided by Raymond. So his thought was that the transgression that entered the Ilumeden Basin was from the Gulf of Guinea, and it was displaced via the Benue Trough, and which was later displaced west. But my analysis showed and aligns with Kobe 1981 and Adetunji 1986 that the transgression that fueled the Sokoto embayment was from the north via the Gao Trench and into the Ilumeden Basin, and later connecting to the Bida Basin. I put this dash line here because of that element that I talked about earlier, that the Widono formation terminated as an embayment. And that, if you put it together with recent studies by Malian scientists, they modeled the Cretaceous paleogeography, and they found that there is no evidence for continuous connection in the Cretaceous into the Ilumeden Basin, that there are some areas of unconfirmed transgression. But if that's, I can hang that, my thoughts on that, that at least the Wuruno aspect of the Sokoto embayment terminated as an embayment because I have upper intertidal to supratidal deposits, and that is an indication that we were close to the shore. So we rushed through this. The basic elements to take away in today's talk is that I have been able to show that we have potential in the Sokoto Basin as far as petroleum system is concerned. Source rock potential, we have it. There are reservoir elements. Some of the outcrop we have seen fractures or faults which are not very much deep-seated, But these fractures are light and they're there. It has also been confirmed by late Obaje and co that they were able to map some faults, and that is possible for that these structural elements are going to help in identifying the most prospective area of the basin. So again, I come back to my okay, will I say, okay, my suggested analog for the Sokoto Basin, especially beginning in the companion, the Taloka Formation. The Brunei Bay is a tide dominated and fluvial influence, as well as some wave influences. So it has been analyzed significantly because the elements for knowing what is really controlling the position in this case are known, because it's a modern example with an adjacent outcrop in the Champion field that has been used to consolidate on this model. Typically, following my interpretation, the tide influence and wave, as well as fluvial influence, the local formation, will sit somewhere around this zone if constructed. So what you are seeing is that you continue to have a basin center and dominated by wave elements, and somewhere here in this middle, what you'll be having are the channel bars that are part of the tide influence and fluvial influence element, just like we have in Taloka. So this is what I'm talking about, basically. The channel bars will prograde, get younger, seaside. It means that to be more prospective, we will be looking at the thickest zones close to the frontier with Niger. And with my prediction or the mapping of the reservoir elements that moved from typically 8 to 10 meters, and the shale or the carbonaceous shale is between 1.5 to 1 meters on average, but Obaje et al., they have found up to 5 meters in well data. And I must say that my data comes from outcrop, mainly outcrop. The only data that came from core for the source rock analysis was from Dange Formation. That is why in the Dange Formation, there are elements that have more TOC, but they appear marginally mature or immature. The Taloka Formation has more maturity in some cases, only isolated, and these belong to the shore face and delta front elements that I identified. So for petroleum system, we have almost all the elements in the Sokoto basins, I believe. So we have identified source rocks and reservoir facies. The structural or the structuration or the structural elements or the trap elements in this basin are likely to be structural traps as well as stratigraphic trap. The idea for the structural trap is because there are fractures that I have seen on the surface of the outcrop, as well as those that have been reported. And the potential for stratigraphic trap is based on the fact that my interpretation indicates that the delta front elements were rapidly deposited with fine-grained sandstone, most of the time sitting, with enormous weight on top of carbonaceous shales. So I have made an attempt or previous attempt. This is from Akande et al. 2018. So it is possible that the petroleum systems found in Anambra basin extend possibly into the Sokoto Basin. So in summary, we have spoken so long, so it's time to break it down. What to take away from this talk? The idea is for you to focus on what I believe is a new input to the study in this area. I have been able to make a suggestion for an analog, and I've been able to put some deltaic progradational deltaic fasces into the picture, which is very important for hydrocarbon exploration activities. Then we have also find out that source rocks in the basin are mainly immature, with a few mature level. The few mature level always come from the shore face elements, the carbonaceous shale that is associated with this shore face. So for a decision to be reached, I know that other workers, late Professor Obaje has done a lot of work. He has recognized some troughs and trenches where he believes can serve as more prospective unit. I narrow that down based on what I have seen and have discussed, and based on my data, that there are higher preservation of sedimentary layers in the northeastern part of the basin. So if I am to say, then the Dukamaje, the Dogodaji, as well as the Ilela region near the frontier with the Niger Republic will serve as more prospective areas. But pending enough data, the problem with this study area is that even the outcrops sometimes appear continuous, but the way they are structured, they are discontinued. If you remember, I showed some channel elements which serve as reservoir along with the short face elements. So those are the kind of elements that would need to be mapped later on, okay, as exploration continues. So again, there are not much data in this Sokoto embayment. I recommend that there's need for us to embark on intense coring campaign to be able to trace the important fasces, that is the source rock and the reservoir elements in the basin. So thank you.
Thank you so much, sir. That was quite intensive. Please, can we put our hands together again one more time for our speaker? Okay, so before we move to the summary and Q&A, I would like to invite some people to the eye table so they can help us to handle that section. So I would like to, first of all, invite our chairman for the day. Please, sir, can you make your way to the eye table? Let's put our hands together for him. Okay, we would also want to invite Mr. Taka, a fellow of NAPI. Please join us on the eye table. And finally, our speaker for today will also be seated on the eye table, so you can take questions and contributions. Okay, so before we move into our Q&A, we'll take a summary. Our chairman for the day will be giving us a summary of everything that we have learned. It's been massive, and I've been taking a lot of notes. So let's just take a high-level summary from our chairman, then we'll delve into the question and answers. Thank you.
Thank you very much. Yes, it's indeed been massive and very interesting. Thank you, Dr. Lawal. And the topic of your lecture was insights into the architecture of petroleum system elements of Cretaceous deposits in the Nigerian Cratonic basins. And in your background, you talked about the Cratonic basins, and you gave examples in some parts of the world, but you did emphasize that there is no major rifting associated. Now, in places like in China, where we have the Ordos, and then you also talked about, mentioned examples in the Middle East and Brazil. And you did say that most are associated with drifting and that they can be epicratonic or intercratonic. Now, you said the focus of this study was on intercratonic basins and that they were mostly surrounded by older basement rocks with the with emphasis on the African case studies. You did mention that a lot of hydrocarbon has been found in some of these basins in places like Libya and Congo, and that the Bida and the Lumedan Basin are part of the Cratonic basins. And Bida is surrounded by massives and is associated with grifting, and that an example of is an example of the Cratonic basin. Sorry, you did say that there's a Williston Basin, which is an example of an intercratonic basin and has produced over 4 billion barrels of oil. And there are also non-conventional reservoirs associated with some of these intercratonics in the Middle Bakken Basin. And your aim was to narrow down. You looked at the Hudson Bay and the Ordos Basin. And in some of these areas where you did mention that, but you also said that your main interest was in the Bida Basin, and that Bida you believe is an extension of the Anambra Basin, and that that there are seismic and core data in the Bida Basin, but data is quite scarce in the Illumidan Basin, which kind of affects your ability to carry out more detailed studies. And due to complex history when it comes to modeling, model is not totally disengaged. I think you mentioned something about Gondwana, okay? And you talked about the stratigraphy of the Illumidan Basin. I wrote quite a lot, but I'm just also trying to narrow it down, just be brief. Now, you talked about the Taloka formation, where you have the lower Taloka, the upper Taloka, and that the Taloka formation is tidal and it occurs in 4 main fascies, which you mentioned to be deltaic fronts, intertidal, lower shore face, and tide-influenced channels, right? And Taloka belongs to a tide and wave fluvial deposit. You mentioned the Dukumaje formation, which is a transgressive element or sequence regionally correlated marine deposit. And we went ahead to talk about the Wurno formation in Sokoto. You did mention that the Sokoto group was Paleocene in nature, and geochemical analysis has been carried out where you determined total organic content, and the highest you found out was about 5.8, though few samples cross 1% TOC for good source rocks, and that the organic matter we see in Sokoto may have quite a lot of gas due to the nature of the sedimentation. Not sufficient maturity, only few samples indicate maturity. You noted it's possible to correlate with the Malian part of the Illumidan Basin, which will actually help us in exploration. And Malian scientists have also noted that there is no evidence of continuous connection with the Illumidan Basin. You've been able to show that there is potential in Sokoto as far as source rocks are concerned, and that we've seen fractures are present in that in the Sokoto basin, but they are not really too deep-seated, and that almost all elements are present in the Sokoto basins, and the traps are likely to be structural, oil has been discovered in some parts, adjacent areas, countries like Chad, and which other one you mentioned? Niger. Okay. So to summarize your discussion, you did say that the Taloka formation is progradational with potentially stacked mount bar channels, and that good stratigraphic studies can reveal prospective sources and systemic mapping of marine horizons. There is a need for systemic mapping of marine horizons and reservoir facies elements is recommended for more successful exploration. One of the big challenges we face in the Sokoto Basin is that there's a paucity of data. And for us in frontier exploration and NMPC going forward, these are some of the challenges we are trying to overcome so that as we move along, we can make more data available for research. And then you ended up by recommending intense coring campaigns in the Sokoto Basin, which I believe will come up as we progress to drill more wells in that area. So I think that was a summary of his presentation. Very nice and educative. And thank you very much.
Okay, thank you, sir. Please, let's put our hands together once again for our chairman. So I would just like to make these comments before I take the question and answer. Dr. Lawal, I think you have the best person to make this presentation to in the house, because Mr. Hussein is actually the manager, business analysis in SAV. So you can hold him very tight as it can help. It's very crucial that we understand what is going on within our frontier basins. I was opportune to work on the Anambra Basin, so I think I can relate to some of the things that you mentioned. So currently we'll be taking questions and answers. So if you have any questions for our speaker for today, please, you could just signify by raising your hands. Okay, we have one here. And those online too, please, in case you have any question, please, you will do well to put it in the chat box. There will be someone to pick it up and we can also read out your questions here. So currently in the room, I've seen just one hand up. Any questions? Or probably you have a comment for the presenter. I know it was a lot. Okay, while I'm waiting for others, I think I will just take the only hand we have in the house. Mr. Alex, please.
Thank you very much. Lovely presentation. My name is Alexander Oshodi. I'm a petroleum systems analyst. In the course of all the research you carried out, a lot of the work you did was basically on the stratigraphy and, trying to integrate the regional geology to understand the petroleum systems. The question I'd like to ask is, at which point in time did you consider, or in your research, because I believe it's ongoing, I think going forward, one of the things you need to consider is your depth to basement. You have categorically stated that the Ilumeden Basin is a cratonic to intercratonic basin, meaning that we do not have any active rifting within that basin. So the basement definition, definitely, it's not like the Benue Trough or the Gongola or the Anambra Basin, where you have multiple structural episodes responsible for the development of the basin. So with this one, do we have any data available in terms of aeromagogravity to be able to understand the depth to basement? Then the analysis you have carried out as regards the sequence of sedimentation across the basin, or at least within the Sokoto axis of it. If we do have a depth basement understanding, then I think based on the work you have done so far on outcrops, it will be easier to create a paleoenvironmental model of the basin. So the concept of source rocks, reservoirs, elements of the petroleum system will be put into play in terms of their respective depths, and that way we can properly analyze the petroleum system. So I think maybe that should be looked into going forward in terms of what your research should be. Then as regards the high maturity values you were getting for some Tmax as regards your geochem, You should also consider the fact that you have identified that most of your source rocks have type 3 organic matter. The activation energy or the activation temperatures for type 3 organic matter are usually higher than what you'd have for type 2, so it can give you a false read on maturity. So you need to take that into consideration as well. Thank you.
Okay, thank you, Mr. Alex. I think I will just take a comment from Dr. Lawal, and if any other person on the high table has a comment. I have 2 questions here online. I don't even want to respond to him first. Then I read the 2 questions. Okay.
Thank you, sir, Alex. You have made an important contribution to this. I have noted some of your suggestions, and I will take them seriously. You mentioned at what point did I decide, or with respect to whether we have this potential or not, especially with regards to Aeromag data. I have not directly worked using Aeromag data, but other studies, if we go by what they found, I think we have up to more than 3,000 3 kilometers of sediment within the Sokoto Basin, which is sufficient, might be sufficient for hydrocarbon formation. But I know that there are other things that needs to be kept in mind, like what's the heat flow, dynamics within the basin. But I also know that in the northern part of the basin, where wells and seismics has been shot, especially in Niger, they have some heat flow, so which can be extrapolated even if we don't have, but that remains to be done. This what I think I would say for the modeling of sedimentary environment. I think that is almost done, but we need more, or maybe a little bit of data to confirm some of the things we are doing. Just to let you know, I have some other data. I have a SRF and a SEM, which I did not include in this presentation. So I think we are still going ahead with most of the things you have suggested. Thank you very much for this contribution.
Okay, I'll quickly just take questions from online. I think somebody is asking here, Christopher Wobi, what is the total sediment thickness in Sokoto Embayment? I think he addressed that now, that you have more than 3 kilometers. Okay. Apart from Tmax, do you have other maturity data for the source rock? Also, do you have any seeps, any evidence of petroleum seeps in the basin? Okay, I will take one more before I take the remaining. Adeola Adeshino is asking you, he says, thank you for your insightful presentation. Your study appears to be primarily based on outcrop observations with limited integration of core data. Given the interest in inland basins and the growing availability of funding, have you considered incorporating seismic and non-seismic data to strengthen your analysis? So basically, it's just asking if you are going to consider other data sources like your seismic and non-seismic data set like gravity and magnetic to strengthen your analysis. I think we can take response to those 3 first, then I'll take the last 2.
All right. Thank you very much for asking this question. So the first person will talk about how much is the total sediment thickness in at least based on what previous studies have mentioned, we have at least 3,000 to 4,000 meters of sediment or depth to basement in the Sokoto Basin. Then Tmax being the only maturity that I have presented, I have also done analysis using the vitrinized under petrological microscope. They also show the percentage we got indicate level of immature to early mature. By the way, I also wanted to do some analysis that has not been completed to do bitumen extraction for us to be able to carry out further analysis to confirm these these results that we are getting. And as for any SIPs, I have not found any myself, but I have listened to people who reported finding SIPs, especially around KB axis of the Sokoto embayment. The second question, questioner was that using outcrop mainly, I have no core data. The only core data I have used, and it came from for the Dange formation. Actually, the difference there, I found a significant difference from the source rock coming from the core data and the one from the outcrop. The core data had better preservation, and as a result, they projected higher TOC level. This is an indication that deeper down, you may have more potential recorded because you are going to have better preservation and you are going to have more enrichment. So, and I have mentioned areas that we can be looking at when we are looking for that kind of angle to it. Then there are no seismics that I can find, although I have read that there is an old seismic shot in the 70s by ExxonMobil, but I've not seen it. If I have access to that kind of data, then that's going to improve our understanding. And I dare to mention that I have read in past papers that part of that result of that seismic survey was that they confirmed that there is close to 4,000 meters thick of sediments within the Sokoto embayment, I mean the Ilimeden Basin. Gravity data has been analyzed, I think. Late Professor Obajo and his team, they made significant effort in that direction. They have used Aeromag, and I think they incorporated gravity. I'm not sure, but this will give us a better understanding of depths to basement and prospective areas. Thank you. I hope that suffices.
Okay, thank you, sir. I think you have answered all of the questions because the last question here from the Jamal is on what type of samples did you do your geochemical analysis? I think you mentioned they were outcrop samples. So the speaker actually used outcrop samples in carrying out his analysis. So I think those are all the questions that we have. Please, can we put our hands together one more time for our speaker for today, Dr. Lawal? Thank you so much. That was a wonderful presentation. I'll be inviting our financial secretary, Dr. Miriam, to do the award presentation. Please, could you step forward, ma? Okay. Okay, before then, I think Mr. Taka wants to say something.
Yeah, thank you very much, the speaker. My name is Alex Taka. We appreciate the wonderful job you've done. Data has been a challenge, and like you've been told, I happen to have also been part of the Sokoto Basin when I was in service before my exit in 2022. We attempted some 2D from Beta Basin up to Sokoto and many other studies that the data should be of help if you find time to make a formal request. The essence of the data is not just to keep it. Every data acquired by an NPC frontier is usually domiciled with NUPRC. That data is meant for research. It's not just meant to be archived. So please, after this presentation, I would suggest you find time, especially as you are waiting Abuja, formally do a write-up so that you get an invitation to see through as much as what you would need to upgrade this presentation. It's very important. Some of us had the opportunity of working up to Wooden cement company of Northern Nigeria in Sokoto and all those places right from our days in ABU, and we are anxious to see what is actually within these basins. And as exploration is going to be sustained, we look forward to, beside 2D, there will soon be some 3D and re-drilling activities to make more data available, and we should be there in a short while. Thank you very much.
Dr. Mutari, please, I'd like you to. On behalf of the NAPI Abuja chapter, I'm honored to present this token to you for your very insightful, engaging, and very enlightening presentation to us. We appreciate you. And would also like to present this flag to our sponsor, Mr. Emmanuel Magjaja. He's unfortunately not able to attend this occasion today. So our chapter president would receive it on his behalf. Thank you so much, Mr. Emmanuel Magjaja. Thank you. Yes, please.
Okay, thank you so much, Dr. Miriam. We're already rounding off the program. So we'll be taking the announcements now. I want to get our announcement slides already. Okay, so I would just like to mention to us that for those of us who are yet to register with SNAPI, please, we are encouraged to do that. The fee for registration for students and non-student members can be found on the website. So you would do well to check it and register for it. We would also like to inform you that registration for the NAPI conference is open, and for as many okay, okay, and I would like to make mention that we will do well to register for the conference coming up in November in Lagos. So if you have not registered, there is the early bird registration. We would encourage you to do that as soon as you can. And for those who are also willing to sponsor, the program is still open for sponsorship. Okay, we have other technical meetings that are coming up. We have one coming up. Okay, we have a technical meeting coming up for the Oka Owerri chapter in August 22, 2025. Okay, and the speaker is Dr. Ebere Bernard, where we'll be speaking on theoretical foundation of deep learning, logic, and basic seismic signal for stratigraphic analysis and reservoir characterization. So we can do well to attend it. I'm sure that the program would also be made virtually available to those who cannot be there physically. Okay. So in case anyone is also willing to sponsor our technical and business meetings, we are open for sponsorship, and you can reach out to the president-elect, Mrs. Olajumoke, or you can also reach out to Mr. Lawrence in the NAPI Secretariat for that. I mentioned that our 43rd annual international conference is also coming up. Its topic is revitalizing the Nigerian petroleum exploration and production strategies for energy security and Sustainable Development. It's coming up between the 9th to 13th of November 2025. You are encouraged to register for it. And also there is call for papers in case you want to make any presentation, paper or poster presentation. I think the call for abstract is still ongoing. Yes, the call for abstract is still ongoing. The deadline for submission is 8th of August 2025. Okay, the NAPE NMGS mini conference is also slated to happen in Kwara State for as many that are interested in attending the program, especially students. You are encouraged to do so. Okay, we would like to also mention that NAPE is celebrating its 50th anniversary, and its theme is Pioneering the Future of Energy in Africa. It will be coming up 14th of August 2025 at the Eco Hotel and Suites. So you can make it down there in case you have the time to do so, or if you're in Lagos or its surrounding environment. Okay, for the Back to School initiative, WIGI, that's Women in Geoscience, is actually calling for sponsorship. So should you want to sponsor, you can reach out to the WIGI group. I think that will be all for now. Thank you so much for listening. As we come to the close of the program, we would like to take a vote of thanks from the president-elect, if she's still available, in the person of Mrs. Jumoke. And afterwards, we'll be taking a closing remark by our Abuja chapter coordinator. Okay. I've just been giving details of the membership dues. For student members, you are just to pay 2,000 naira annually, while active and associate members are to pay 12,000 naira. Corporate members are expected to pay 50,000 naira. So it's very key that you pay your dues, and you can check the NAPE website for more information on how you can join or register and become a registered member of the association. So, Madam Jumoke, please, can you confirm that you are available to give us the vote of thanks?
The president-elect is not online presently.
Okay, then we can take from the president if he is present. Mr. John Bosco, please.
He's not online too right now.
Okay, I think our chapter president will just give us the vote of thanks and also our closing remark. Please, can we put our hands together for...
Thank you so much. Thank you so much for your time. I want to appreciate you for sitting quietly and then learning from our professor here. I call you Prof on this subject. So we had an insightful and enriching, thought-provoking subject today. And I want to really know that we have a valuable perspective on this subject, and we've actually broadened our knowledge of the Sokoto basins. Before, like I said earlier, we were seeing is limestone that we have in Sokoto basin, and all the Illuminum basins, Borono formation, we have gypsum on the Bida basin. It's quite cheering that we are having trace of oil. And I know with further exploration and studies, we are going to discover economic quantity of our oil, of our hydrocarbon. Thank you so much. And I want to also appreciate the depth of research and clarity in which you divulge this subject is so cheering and so amazing. Thank you so much for coming. And I also want to thank our guests, our attendee for coming, and also our online attendee too, for your patience. This is NAPE Abuja chapter, and we have various activities lined up. We've had our first, second, and this is our third meeting that we're having today. We also want to inform you that we're going to be having not just one, two other activities in August and probably September. We are going to have a fourth technical meeting, which is going to be a very interesting topic. And we have our experts in the oil industry coming to do presentation for us. we're going to be, we're not sure if it's going to be hybrid, but we'll let you know. We communicate this to you in due course. And also want to also intimate you about our YP program, Young Professional Mentoring Training activity coming up very soon. And I want to encourage our young professionals to please come around. It's going to be an interesting one too. We are inviting experts from our oil industry to come and deliver the interesting programs, topics to us too. So without taking much of your time, thank you so much for coming. And we are going to, like they said earlier, the conference is coming up in November, please. National conference in Lagos, Eco Hotel. So if you can make it, please do come. And we'll also be inviting up our student chapter too. We'll see if we can do a little of sponsorship. We want to invite our fellows here, our senior colleagues for sponsorship. So we want to ask and want to come and visit you also in your organization, agencies too. So thank you so much, and I wish everyone safe trip to your various destinations. Thank you and God bless. Have a group photograph, please. Let's come together, have a group photograph. Okay.